let's take a look at the following function. Now I have a function f of x, and we have a point on this function. Let's call it p. Let's say coordinates a, comma. Can anyone give us the y coordinate? If x is a, what will the y coordinate be if the point is on the graph of the function? Can anyone give us the y coordinate if the x coordinate is a?
F of A?
Of course, thank you very much. Absolutely. Good. Now, let's suppose we draw the tangent at this point. So this is the equation, or this is the line that is the tangent at P. Tangent at point P. Now, the next question is, what is the slope of this line? Can anyone give us the slope? The slope of the tangent at P. What will it be given by?
The derivative?
Thank you, thank you, thank you. It's the derivative evaluated at what point? Or for what x value?
At P?
Yes. And what is the x value for P?
A.
That's it. Very good. Awesome. Thank you very much. That was very good. Okay, so now I can determine the equation of the tangent line. I have the point and I have the slope. Which equation do I have to use? Just dictate it and then I'll replace what I need to replace by. What equation will I have to use to find the equation of the tangent line at P? Y well, this is the algebra. This is not even calculus. Y minus
Y1.
yes equals
M.
yes the
times
slope times x minus x1. Brilliant. Thank you very much, Jesse. Now here's my a, which is x1. Here's my f of a, which is y1. x1, y1 come from the point, and the slope, this is f prime of a. I replace everything now. Y minus f of a equals f prime of a times x minus a. I will put f of a to the other side. It's negative here, and I move it to the other side. It becomes positive. Okay. So this y is the equation of the tangent line, and this is a function. What do you mean is a function? Yes, it's a function. It depends on x. So this function, we are going to call it uppercase L of x, is because it's not the same with the function. I don't want to use f of x. I have to use anything else. So we're going to say L of x is f of a plus f prime of a times x minus a. This is the linearization of function f of x near this point. What do I mean by near? near this point, not here. This is point Q. I'll have a different equation of a line that is the linearization of f of x at this point. Here, a different one, a different tangent, a different L of x will be the linearization of f of x at this point. So that's why I say near, and I'll explain in a moment again why I say that. But let's just write down first L of x. I lost my page number. So this is 4. This is 5. So L of x, the linearization of f of x near P, or in other words, x equals a. Near x equals a. What does it mean? Why do I need this linearization? It means this, that if I need to approximate the function or evaluate, if I need to evaluate the function at this point, near the point, I could use the equation of the line. The error, there must be an error. If I use the function, I will not have an error. But if I use the tangent to evaluate the function near this point, I will have a minor error. If I can live with that error, I can use the equation of the line to evaluate f of x near the point, or near x equals a. That's why this is called either the linear approximation or the linearization of a function. What does it mean again? Any function can be approximated with a line near a particular point. Any function can be approximated by the equation of the tangent at that point, near the point. That's all it means. So it's either called the linearization or the linear approximation. Again, any function can be approximated by a line. I'm going to write that too. Any function can be approximated, or the linearization can be determined, in other words, can be approximated by a line near a point. Of course, the function has to be differentiable at that point, so all these conditions have to be in place. But any function can be approximated by a line near a point. Of course, maybe I should write this, where I should say, it is differentiable. I want to practice this with a couple of examples, and then we'll come back to the rest. Let me see which page. Okay. Where is my book? My book. I'm clicking. Okay, vital source. So page 341, if you're already there, we can choose the linearization. Okay, page 341. I'm sure you can get there faster than I can. I'm almost there. Okay, e-text, chapter 3, 3.6, e-text, 341. So we'll come back to the rest in a minute. Find the linearization of f of x equals x squared, x cubed, the square root of x, 1 over the square root of x, e to the x, natural log x. So we want to practice the linearization. Finding the equation that approximates the function at that particular point near that particular point. Any preferences? No preference? Okay, I'll take 21 on page 341. And this is h of x equals the square root of x. Find the linearization, part A, L of x of h. Oh, I called it, yeah, it's h, okay, at a equals 16. All we have to do is start with L of x equals f of a plus f prime of a times x minus a. This is the definition. We just developed it together. So L of x equals f of a plus f prime of a, x minus a. So the function is this. F of a will be f of 16. The square root of 16 is 4. So I already have this, which is 4. I already have this, which is x minus 16. All I have to do is differentiate the function, no problem. Sorry, I wrote f. So let me change it to h because the function, I don't want you to get confused. So it's h of a. So h prime of a will be 1 over 2 the square root of a. So this will be 1 over 2 the square root of 16. The square root of 16 is 4. 4 times 2 is 8. So the linearization equals 4 plus. This is 1 over 8. And this is x minus 16. Let's stop for a moment and see if you have any questions. Stop for a moment and see if we have questions before we continue. This is not done because I have to solve for L of x. I have to distribute and a couple of steps there. And then I can move on and answer the rest of the questions.
Can you re-explain how you got 4 from the 16?
You mean here?
Yeah.
H of x is the square root of x. So when I plug in a, the square root of 16 is 4. Is that okay?
Yeah. So if it was like a different function, like x to the third, you plug it in and then find that out and then match
Yes.
your a.
Yes. Yes. So that's the formula. So for any point a f of a, when x is a, I can determine the linearization of the function at this point, meaning I can find the equation of the tangent line that can approximate the function near the point. So I have f of a plus f prime of a times x minus a. And what I have to do is plug in 16. 16, 16, 16. So with the 16 here I get 4. With 16 here I get x minus 16. And here I have to differentiate first, which is 1 over 2 the square root of a. The square root of a is the square root of 16, which is 4. 4 times 2 is 8. So that's why I have h prime of a 1 over 8. Is that okay? Yes? Is this okay?
Yes.
Other questions? Anybody? Were you able to follow this? Okay, so then L of x equals, I distribute 1/8 x 1/8 times 16 will be -2, and -2 plus 4 is 2. This is final. Again, what does this mean? This function can approximate the square root of x near 16. Will I have an error? Yes. But the error will be minimal, because any function can be approximated by a line, which is the equation of the tangent line, near a point, of course, where the function is differentiable. Okay, so this is part A. We determine the linearization of the square root of x only near 16. If you change 16 into 25, it will be a totally different function. And if you change it at other points, of course, a different function. Okay, so now in part B, they want, what do they want in part B? It says, use a linearization to approximate the square root of 17. Okay, so what is x? What do I plug in? How much is x? In part B. Can anyone tell us what is x in part B? What do you think? Anyone, please?
Is x 17?
Yes, exactly. That's what we have to do. Perfect. Good. So we are going to plug in x equals 17 in the linearization. So we have L of 17, which is 17 divided by 8 plus 2. And we will approximate this. Very good. Here it is. And we have 17 divided by 8, and then plus 2. So 4.125. So L of 17, 4.125. There is no need for the approximation symbol. I'm going to take care of it. Good. So that was part B. Let's see what they want in part C. In part C, they want find the square root of 17 using a calculator. Okay, fine. The square root of 17 is, that's part C. The square root of 17 is 4.123105626. Okay, let's see what they want in part D. What is the difference between the approximation and the actual value of the square root of 17? Okay, so part D, difference. 4.125 minus 4.123105626. So back to the calculator, I'm going to say minus the previous answer, and I'm going to I don't know if it's going to do it though. We'll see in a moment. No. Okay, so what I wanted is 4.125 and minus the square root of 17. Okay, so the difference is, the error is 0.00189437444. And the question is, oh, I don't think I shared. Did I share? I didn't share. Sorry. So 4.125 minus the square root of 17 is this. So can you live with this error? I think so. So the linearization gives us a very good approximation of the square root of 17. And that's how they do it a long time ago when they we're thinking about taking the square root of 17. That is a very good approximation. They change the function into a line. You can always do that for any function, with any function. They changed the function into a line, and they plugged in 17. And they said, oh, that's it. Any questions about linearization?